All right, so far we have discussed simple interest, compound interest, and the future value of an annuity. Okay, so now we're going to turn our attention to the next formula on our formula sheet, which is the continuous compound interest formula. It's this formula right here. Okay, so if you go into D2L, there's a separate note packet for continuous compound interest. It's very short, it's only 2 pages. So here's what the first page looks like. So let's start reading about it. Continuous compound interest is a form of compound interest in which the number of compounding periods per year increases without bound. In other words, the interest is being added to the account all the time. And the formula for continuous compound interest is A is equal to P times E raised to the R times T power. Okay? All right, so first of all, what you've got to realize is that continuous compound interest, it is a form of compound interest. Okay, so what that means is when do you want to use this particular formula? Well, under the same kind of circumstances, you would use compound interest, regular compound interest. You would be saving money through a one-time deposit. Okay, but the difference between the two, the difference between regular compound interest and continuous compound interest is that with continuous compound interest, the interest is being added to the account all of the time. Okay, so what's going to happen here is there is no M value for continuous compound interest. You don't see an M value in the formula. Okay, because M is indicating how often the interest is being added to the account. Okay, so if the interest is being added to the account all the time, what would you plug in for M? Okay, so that's why there's no M in the formula. Okay, the great news about continuous compound interest, it is the easiest formula in chapter 3 to spot. Okay, if it is a continuous compound interest problem, you will see the phrase compounded continuously in your word problem. Okay, so as soon as you see that phrase compounded continuously, you know, hey, I've got to write down the PERT formula. I call it PERT for short. Okay, so with this formula, okay, the variables A, P, R, and T have the same meaning that they do in regular compound interest. Okay, so remember, let me write this over here so that you can recall. Okay, so for regular compound interest, here's the formula. It's this formula I'm talking about. Okay, this one. So you would have an M value for regular compound interest. Okay, so the A, the P, the R, and the T have the same meaning. Okay, so A is the account balance. P is the amount of the original deposit, which is that one lump sum. R is the interest rate as a decimal. T is the time in years. Okay, regular compound interest will have the M value, which is the number of compoundings per year. Continuous compound interest does not have that M value because the interest is being compounded all the time. So the other thing we need to talk about with the PERT formula, okay, is this E thing, okay? E is not a variable. It is a number. E is a number, okay? So if you scroll down a little further, okay, right here, okay, E is this number, okay? Hopefully you've heard of the number pi before, okay? So pi is a decimal. It does not repeat. It does not stop. It is approximately 3.14, okay? That's what pi is. E is a very similar type of number. It is a decimal. It does not stop. It does not repeat. E is approximately 2.71, okay? So because this is finance, okay, you do not want to round E in the calculations. You need to use the full decimal expansion of E, okay? If you don't do that, then your answer is going to be off by a few cents or even more, okay? So I'm going to show you how to work E on your calculator. There are 2 E buttons on your calculator, so let's familiarize ourselves with that, okay? There is just an E button, and that is going to provide you with just the decimal expansion of E, okay? The other E button allows you to raise E to a power, okay? And that's probably the one you're going to want to use more of, okay? Because if you look at your PERT formula for continuous compound interest, you have to raise e to the r times t power, okay? So this one will allow you to raise e to a power. Okay, so let's go take a look at the calculator so you can see where these e buttons are. Okay, so here we go. Let me clear this out. So the first button for e on your calculator, and if you have a different calculator, you'll have to like look at your calculator and see where your buttons are, and you can always ask me if you can't find them. For me, the E is associated with the division key. So if you can see where my arrow is hovering, above the division key in blue, it says E, okay? So I have to call up the second function. So second division will bring up the E key. And if I hit enter, it will just give me the decimal expansion of E, okay? But like I said, the other button's probably more useful because it's going to allow you to raise e to a power, okay? That other E key is associated with the natural log button, which is right here, okay? So again, it's e to the x right here above the ln key, okay? So if I hit second ln, okay, that's going to allow me to raise e to a power, okay? So I'll make something up here since we're not in the middle of a problem, but you're going to be raising e to like r times t. So I'll make up an interest rate. Let's say we've got, I don't know, 4% times 7 years, okay? So that's how you would do e raised to the r times t power, okay? So those are your two e buttons, and like I said, e to a power is probably the one you're going to want to end up using, okay? All right, so let's go ahead and try an example, okay? So if you go down to the bottom of the page, let's take a look at example 1, okay? What amount will an account have after 1.5 years if $8,000 is invested at an annual rate of 9% compounded daily? Assume a 365-day year. Okay. All right, so what's going on here is you are saving money. You're saving one lump sum of $8,000 for 1.5 years. The interest rate is 9%. And we're told that the interest is being compounded daily, okay? So you're investing a one lump sum, okay? And you have an M value here, okay? The interest is being compounded daily, so it's 365, okay? For that reason, that makes this a regular compound interest problem, okay? So this would be the formula you would use here because you're investing one lump sum, okay, and you actually have an M value, okay? So let's go ahead and plug it in and see how much our $8,000 grows to be after 1.5 years, okay? So we've got our M value. We are looking for our account balance after 1.5 years. P is the amount of the original deposit, so that's $8,000, okay? R is the interest rate. I'm going to take my 9% and convert it to a decimal. And then T is time, so that's 1.5 years. Okay, so let's go ahead and plug all of this in. All right, so we're going to get 8,000 times 1 plus 0.09 divided by 365 raised to the 365 times 1.5. Okay. All right, so let's go figure out our account balance if the interest is compounded daily. Okay, so back to the calculator. I'm going to clear this out. So let's go ahead and punch this in. Let's see. All right. Okay, I'm just going to put the exponent in parentheses to be safe. All right, so here comes our account balance. Okay, so this is going to be money, so we need to round to the nearest cent. So let me go ahead and write this answer down in our notes. Okay, let's see here. This is the number we get out of the calculator. All right, so let's round. Okay, so we've got 14 cents. There's a 1 that comes after, and so that means we're going to stay the same. So after 1.5 years, you have an account balance of $9,156.14. Okay. All right. So that was still regular compound interest. Okay. In Part B, it's the same situation. You're still investing $8,000 as one lump sum for 1.5 years. Interest rate still 9%. Okay. The difference here is now the interest is going to be compounded continuously. Okay. So as soon as you see this phrase continuously, you know that we're going to be using the PERT formula. Okay. Instead of the regular compound interest formula. Okay. All it takes is that word continuously. Okay. All right. So the variables mean the same thing. Remember, there is no M value now. That's gone. It's not part of the formula. Okay. But we will still be looking for the account balance. Okay. How much will our 8,000 grow to be if the interest is now compounded continuously instead of daily? P is still going to be the one lump sum that you deposit, which is the $8,000. Okay. R is still 9%. Time is still 1.5 years. Okay. So we're going to plug in to this PERT formula instead. Okay. Again, you're going to use the E button on the calculator. You don't want to put in 2.71 for E. You don't want to round it. Don't do it. You'll get the wrong answer. Okay. All right. So E is going to be raised to the 0.09 times 1.5. Okay. And so now let's go to our calculator and see what we get. All right. So we're going to get 8,000. Okay. I'm going to do second natural log to bring up E to a power. And then E is going to be raised to the 0.09 times 1.5. Okay. And you might be wondering, well, okay, the interest is being compounded continuously now instead of daily. The interest is being added to the account all the time. So maybe I'm going to get a much larger balance. Okay, we're about to find out. Okay, here you go. Look at that. Okay, you get almost the same account balance. It differs by a few cents. Okay, but just because the interest is compounded all the time, that doesn't mean you get a whole lot more money, because you don't. Okay, so that might be surprising to you. All right, so let's go jot this down. Okay, so what came out of the calculator is going to be this number right here. All right, again, we need to round to the nearest cent. Okay, so we have 29 cents. Look after, it's a 4, so we're going to stay the same. So from doing continuous compounding instead of daily compounding, our account balance only went up 15 cents. So our account balance after the 1.5 years will be $9,156.29. So not a huge difference at all, unfortunately. Okay. All right, so that's how you work with the PERT formula. And let's go ahead and try a couple of more problems.